I might talk, and today my topic is air pollution and respiratory health in children. Evidence from a population-based cross-sectional study in China. As we know, air pollution is a global environmental problem, particularly in some areas in Asia and Africa, such as China, India, Egypt, and India. Um, According to the annual report on environmental quality released by Chinese EPA, the annual concentration of PM 2.5 in 30 capital cities were higher than the 10 micro per cubic meter, which is the suggested level set by WHO, and 20 out of 30, and the 20 out of 30 cities exceeded the Chinese the Chinese standard level set at 35 micrograms per cubic meter. And I know that, so from this figure, we can see that the air quality in 2014 in China was that's terrible. And so Chinese government spent a lot of money, probably more than 70 billion Chinese yuan, which is approximately equal to 11 billion US dollar to control air pollution from 2016 to 2019. And we can see in this figure, the air quality is getting better, and the concentration of the PM 2.5 level decreased up to 60% compared to those in 2014. And we have 12 capital cities achieving the air quality standard of the guideline level. So the most polluted areas still mainly located in North China, and we have to take great effort to get the air pollutant levels down to meet the guideline level in China. And when it comes to the human effect with air pollution exposure, researchers proposed a nonlinear exposure response relationship between air pollution and health outcomes. In the nonlinear curve, the association between PM 2.5 and disease incidence is different at different exposure range. It seems that the increasing risk in the curve getting smoother when PM 2.5 level are quite high. So we conducted our study, a cross-sectional study in the North China, and we selected our study location in Liaoning province, which is a heavy industrial area. In this investigation, we aim to investigate the associations between air pollution and children health. And actually, there are 14 cities in Liaoning province, and we select 7 cities based on the annual mean concentration of the long-term air pollutant to maximize the inter and inner air pollution gradient. So from April 2012 to January 2019, we select 7 cities out of 46 cities. In each cities, we randomly select 50 kindergartens, 24 elementary schools, and 24 middle schools from each, from the all the 7 cities. And the 7 cities includes in total 28 districts. And we select the school. Well, actually, that's the 1 to 2 kilometers near the local air monitoring station. The reason we do that because in China, child's home and school, they should at the same community so that children can go to the school in community. That means the air pollution level should be similar in home and in school to some extent. Well, in this next study, we choose the participants. They should live at least 2 years in the local residence. And so in total, we recruited 17,000 children in SNEC study. We collect various outcomes through the questionnaires. On the basis of the investigation, we randomly select 1 or 2 classrooms from each grade of elementary and middle school. So it's about 10,000 children. We give them the basic physical examination. So in the SNEC study, we collect information of environmental exposure, including air pollution, greenness exposure, household exposure, such as the environmental tobacco smoking and pet keeping. And the outcome in children we collect include the height, weight, and lung function tests, asthmatic symptoms, and other allergic or infectious disease information. And also we have the blood information measurement. We all know that, well, for the air pollution exposure assessment, we have 2 data sets. One was from the air monitoring station, including PM10, nitrogen dioxide, sulfur dioxide, and ozone. Because the PM2.5 was not more governmentally monitored until 2019 in China. So we use the machine learning method of validating and commonly used land use regression model to predict the PM1, PM2.5, PM10, and nitrogen dioxide concentration. So in today's talk, I will present some results we have found between air pollution, asthma, and lung function. We all know that asthma is the most common pediatric disease presenting an episode of wheezing, cough, and shortness of breath with various severity. It's estimated to have affected 14% of children globally, and has been shown to be associated with significant economic burden and other, and in both developed and developing countries. But it's not clear why some people get asthma and others don't, but it probably due to the joint effects of genetic and environmental factors. The air pollutants include particulate matters and gaseous pollutants as well. And increasing evidence show that the air pollution exposure is associated with triple asthma exacerbation. And it has been reported that air pollution accounts for 18 to 42 of the estimated percentage of pediatric asthma in US. So in this next study, we here is present the PM1, PM2.5, PM10, and nitrogen dioxide of the 4-year annual mean concentration. And we can see that the concentration, the mean concentration is quite high, and they all exceed the WHO guideline because we don't have the PM1 suggested level, so it's not available to compare. But basically, we can see that the air pollution, particularly for the PM, particulate matters, they are very high in the SNEC. And here in the our participants, the prevalence of the current asthma we selected as the entry point. The prevalence for current asthma is about 2.8%, and the current cough is higher than the asthma, is up to 60.7%. I know the prevalence is lower maybe than the most Western countries. So we analyze the association between the PM and the asthma in children. And we can see a clear patterns that higher exposure to the PM1 and PM2.5 and was associated with the increasing odds of asthma. And the increasing trend is similar for the nitrogen dioxide. Since we found the association between the particulate matter and asthma in children in the SNEC study, we wonder if we can find some modifiers such as the beneficial risk to attenuate the adverse associations. As we know that breast milk is the contain the ideal nutrition for the infants, nearly perfect mix of vitamins and proteins and fat. So everything that your body needs to grow when you're a child. So many medical experts strongly recommended breastfeeding exclusively, not formula, juice, or water for 6 months. So for 6 months child. But in SNEC, we can find that we select the breastfeeding information. We use the 3 months as a cutoff value because in China at that time, that the mother they have need to go back to work if they just take the 3 months leave for the pregnancy for the the nursing. So from the 2007 to 2008, and the breastfeeding rate is relatively high, it's almost 90%, but 5 years later, that breastfeeding rate dropped, that significantly, that to 67%. So in the SNEC study, we analysis the modification effect of breastfeeding. In the data analysis, we found that the children had breastfed had a lower asthma than those without the breastfeeding. So it seems that the breastfeeding can modify the adverse association between air pollution and asthma in children in this data set. And another modification we found is the vaccination. We know that vaccination is one of the most effective ways to prevent the infectious diseases. And a vaccine can help the body immune system to recognize and fight pathogens like the viruses or the bacteria, which can keep us safe from the disease they cause. Currently, the majority of children receive their vaccine on time, but nearly 20 million the worldwide children still miss out. So in the SNEC study, we found we collect the flu vaccination information, and among the 70,000 children, about 40% children have the flu vaccination. And the flu vaccination we define as if the child received the trivalent inactive influenza vaccination in the last 3 years. And the outcome of interest we choose asthmatic symptoms. And from the figure, we found that the black diamond is the children without influenza vaccination, and the blue diamond is those with the influenza vaccination. Compared to the non-influenza vaccination children, those with the vaccination had a lower odds of asthma compared to them. So it seems that influenza vaccination they may mitigate the adverse relationship between the air pollution and childhood asthma in SNEC study. Well, another potential modifier could be the pet ownership. Because aside from the outdoor exposure, indoor exposure is quite important and receive more and more attention, because in modern society, household is more likely to have pets in home. And actually nearly 50% of the US household have dogs, and the number could be higher and get to 65% in New Zealand. So we know that pet ownership, they may also have they may act as the source of the indoor allergen and endotoxin exposure. So we don't know if the pet ownership can modify the association between the air pollution and asthma. So in this next study, we analyzed the modification of pet ownership, and interesting, we found that in children who have pets, they have the lower asthma risk compared to those without pets. Even we can find that even that the association between air pollution and asthma, they have a positive association, but the association becomes null in children with pets. And when we categorize the pets into different categories, and we found dog and bird ownership, they can decrease the association between asthma and air pollution exposure in the SNEC children. And well, now that maybe the beneficial factors, maybe the greenness exposure, because greenness, we know that there's, oh, sorry, this is the, probably I just copied that from the previous slide. And greenness is related to the urban planning in a model society. It's very important in the human life. And greenness can, maybe they can reduce the ambient air pollution levels, and also give, maybe can enrich the microbial flora, and the microbial diversity can be directly related. We in that study, we used two index of the greenness exposure. One is NDVI, then a normalized difference vegetation index, and another is solid adjusted vegetation index, SAVI. These two are normally and commonly used in the greenness exposure. In our data analysis, we found a clear pattern that higher greenness exposure was associated with lower asthma in children in both well, asthma and with episode. And when this association, when we see if the air pollution, maybe we can see if this association can be modified by the air pollution, because air pollution is associated with the greenness exposure. So we well, here we separate the air pollution into lower exposure and high exposure. The low exposure is the first quartile of air pollution, and the higher is the level higher the first quartile. So we can see that the beneficial association is much significant in the higher air pollution exposure areas. So that so that beneficial association between greenness and school asthma, they this association could be appear to be more significant in the children, the exposure to the higher air pollution levels. Well, we know that the obesity is the global common problem in children. And in our study, we found that obesity and the overweight children, the adverse effect of air pollution and the asthmatic syndrome was higher in that obesity children. So that seems obesity can enhance the association between air pollution and the asthma in children. So from this part, the summary. In our data set, we found that the long-term exposure to air pollution was associated with the higher odds of asthma. And at the same time, breastfeeding, influenza vaccination, and pet ownership, greenness exposure, they may modify the association and attenuate the asthma symptoms in children exposure to the higher air pollution. On the other side, obesity, they can be added as an important modifier that which enhance the risk association between air pollution and children asthma. And second part, I'm going to give you some present some result on the lung function. As I presented in previous slides, we have almost 10,000 schools to give the basic physical examination. And here the skin that we measure the lung function. First, we randomly select 24 elementary and 24 middle school children, and the response rate is 97%. Then we excluded 4% of the children who do not live more than 2 years in the local area, and excluding 1% children who did not complete the questionnaire investigation. So finally, we have 6,740 children in the SNEC study with the lung function measurement. And the lung function we measure for index FVC, FEV1, PF, and MAEF. And we define the impaired lung function with, we have two definitions. One is using the cutoff of FEV1, FVC, MAEF, and PF. And we also define the impaired lung function using the airflow obstructive and spirometry restricted. So in this next study, the prevalence of the lung function reduction using the first definition is we have the FVC impairment of children is about 11%. If you use the obstructive and restrictive definition, we found that the spiritually restrictive children have this symptom is about 60.8%. And first, we analyzed the air pollution and the lung function. We found the clear increasing odds of asthma with the per IQR increasing of the PM1, PM2, PM10, and nitrogen dioxide levels. That the pattern is clear for all four index. And we're using the Zeng strategy to analyze the data set. We analyze the modification of the breastfeeding, and we found that the blue dots are children with the breastfeeding, and the red dots are the children without the breastfeeding. From this figure, we found that the breastfeeding with the lower odds of the lung function impairment in these children exposed to particulate matter exposure. And this data was published at the JAMA Never Open, and the editor-in-chief of this journal gave us a comment. They said, everyone will agree that air pollution is bad and should be eliminated. However, our study provided information on the individual parameters. They what can they do to protect their children? And the editor-in-chief, they agree that the protective effect of the breastfeeding may be important for the the intervention. And let's see the influenza vaccination and modification. The children with the influenza vaccination, they have the lower, the FVC reduction compared to those one without the influenza vaccination. So since that the influenza vaccination, they significantly modify the adverse effect of the ambient pollution and lung function in our children. Well, when we get into the greenness exposure, here we found we used two endpoints. One is the airflow obstruction, and the other one is spirometry restriction. And we found that higher greenness exposure was associated with the lower odds of the respiratory restriction, while the airflow obstruction, the association was null. And then we see if the air pollution may modify the effect of the association between greenness and lung function. We found that, interestingly, at a high level of the PM exposure, we can't find the beneficial effect, but at a moderate or lower level of the PM exposure, we can find the beneficial effect of the greenness exposure and the lung function. Finally, let's see the obesity. Similar results as what we found in the modification of obesity on the asthma and lung function. Children who are overweight or obese had higher, the lower lung function in those children compared to the normal weight children. So in this part, I give you a summary, and we found that the exposure to the air pollution was associated with the lung function impairment in children, and a similar effect of the breastfeeding, influenza vaccination, greenness exposure as the asthma, they may add the beneficial roles on the modification of air pollution and lung function impairment. And obesity is an important modifier which enhance the adverse effect between the air pollution and children lung function. This is what we have done in the SNEC study. I'm going to give you a short introduction of what we are doing now. We are conducting the Pole River Delta cohort study. Here is the scientists. They collected 10 PM components from the globally, and they use the normalized index of Alston generation as the health effect. They found that Guangzhou, the particular collective from Guangzhou, have higher PM 2.5 toxicity if they're using this index. And here is the research selected the PM from the different countries, including the Asia and also the Africa and also the US. So another, we do more research work, and we found that some has published that the PBD is one of the persistent organic matter, and they analyzed this component in the PM in different cities in China, and they found a higher level of PBD1 PUF component in the PM2.5. So we know that maybe the total concentration of PM2.5 was lower in Guangzhou compared to some cities in the North China, but the toxicity may be higher. So we don't know. And what we have done this next study is we mainly focus on the children in North China because the Science University located in Guangzhou, so we conducted the Pearl River Delta study and have the 6 cities in this area. We conducted this investigation from 2016 to 2017. This is the first round, and we already finished this first round investigation. We have collected 130,000 families information. We collected outcome in children, including several health outcomes and also the outcome in adults. And at the same time, we selected 1,000 children, and the mean age is 10 years old. And we measured the lung function for 3 consecutive years from 2018 to 2020. So this is the lung function cohort in Pearl River Delta. This is a subpopulation. We also collected the PM, including PM1 and PM2.5 in this school, because these 113 family, 1,000 family information, they were all from these 127 schools. So we conducted the PM collection. We have 2. Well, in each year we have 2 sampling. One is in the wet season in Guangzhou, it's from May to August, and another is dry season, November to January, from 2016 to 2018. And we analyzed the traditional and emerging compositions in the PM. Here's the rather result. From the 6 cities, we found that PM and PM2.5 level, actually they don't have the season variation except for the Zhongshan and Shenzhen city. And in addition, we calculate the ratio of the PM1 and PM2.5. We found that PM2.1 contribute to the 80 to 100 of the PM2.5 total mass. Because we analyzed some traditional components in PM, for example, the heavy metal. Here's the blue is the winter season, and the pink is the summer season. We can see for some cities they have the seasonal variation, even though the total mass concentration they don't vary too much, but the components in the PM they vary and they are different at different seasons. This is one emerging component of the analysis. It's the PFAS. Because perfect alkyl substance is one kind of the the chemical, and they have the legacy PFAS and also have the alternative PFAS. We found that compared to the alternative, the dominant component of PFAS is still PFAS, which is a very well-studied PFAS. We can see that they have a much higher concentration compared to, among other PFAS components. Well, actually, we conducted the second round of the Pearl River Delta study from last year because we know that COVID-19 is a pandemic. Well, this big event changed people a lot, including the social behavior and maybe the way you think about the life and the world. So that's why we decide to conduct the second round. And the second round from 2020, we select 4 cities because for the first round at the baseline investigation, we select 6 cities, and we found some cities had the air pollution variation, seasonal variation, but some don't. So we choose 2 have and 2 don't have the seasonal variation. And so that in this second round, we collected 17,000 families, just half lower than the first round. But I think that's enough because these like the cohort, and for the first round it took us almost 2 years to input all the data and clean the data, and including the health outcome information and the questionnaire, and also the too much variables. So the second round we only have 70,000 families. So each family we collected children's information and the parental information and the grandparental information. Here is this, but we added some other variables because we this round we focus on the COVID-19. So, but I did not present it here. We had many items in our questionnaires. So this is what we've done in our research group, and our research group PI is Professor Guang Huidong, and we have 1, 2, 3, 4, 5. We have 5 other faculty members, and 1 research fellow and 1 postdoc, and 30 PhD and master students. This picture was taken last year because of the lockdown, and the students, they cannot come back. Only the graduate students can come back. So just a few of our member of our research group. So well, we are looking forward to more cooperation if you are interested with our group. So thank you.
Thank you, Shawan, for a fantastic talk.
Take questions.
Yeah, so it's a fantastic talk, Shawan. So you have conducted very large studies with a lot of information, and it's very valuable resources. Especially, it's very interesting to see the effect of air pollution on asthma and lung function with a lot of effect modifiers. And it's now open for the questions and comments from the audience. Any questions or comments to Shawan?
Thanks very much, Shawan. I knew about the SNEC study because you involved some of us in one of the analyses when you were in Melbourne, but you've been incredibly productive. There have been quite a number of interesting publications on lung function. One thing that I wondered about, do you think the effect on vital capacity is independent of height? I mean, is it possible that the children who live in the greener areas are better nourished and grow to be taller?
Well, yeah, we haven't think about that in that way. So your comments that if then possible that children live in a more green spaced area, they may taller. Well, I think the body growth may be related to the nutrition, and or maybe also the social economic status of the family, and in our data set, well, these people, they are all they live in the city, so the very few people in the they're all the urban. So the economic the economic data, maybe they don't have the much variation. But it's interesting that your question is very interesting. If the people like grow taller if they live in the green space, but I don't know the biological mechanism for that. So Mike, could you talk about more? Maybe is it the biological mechanism?
Well, I don't know, I'm just speculating, but we do know, for example, that children who are exclusively breastfed tend to grow faster and tend to be taller over the long term. Anyway, I just raised these issues. You published the data, so well done. I think generally many of your findings are consistent with what is understood about the immunology of asthma. So breastfeeding obviously gives children access to passive immunity from secretory IBA. Greenness, greater exposure to biodiversity, pets, also exposure to microbial diversity, and obesity is pro-inflammatory. I was just wondering, are members of your research group proposing any mechanistic studies to understand the underlying pathophysiological mechanisms?
Yeah, it's a good point. Thank you.
Thanks, Joanne. Really nice presentation. I think that when your group presents, I have always noticed that there's so much work on each of these topics. So it's not just you have done a study and you have published X number of papers, but if you look at each area, you have published quite a bit. And what you presented today was the findings, were the findings from the childhood asthma. But when I have seen Professor Dong presenting, for example, like he also has focused on a particular area, and then we realized that you have published so much in each area. So well done. Just going back to Michael's comment, the physical activity, the green area and the height, could it be related to physical activity? I don't know what greenness means in China. Does that mean there are lots of parks, or there are lots of playgrounds, or it's just green areas that are developed just to kind of maintain the greenness? I guess it depends on what greenness means here.
Yeah. Exactly. And the greenness index we use in the SNEC studies only NDVI and SAVI actually is a core assessment of greenness, because they cannot distinguish if there's a brush or the forest or the grass. For this two index, they can not give this information. So they limit our the mode of explanation of the what we found. So so now we have another index of greenness. Is what we call it. It's eye level greenness. They use the different. They use the eye level side. They just like a picture shows. But I don't know the method how they predict the greenness, but they can give the different greenness type, like is there a tree, flower, grass, or just the different kind of the greenness. They can present it using a new greenness index. I think if we use that index, we can have have more evidence or can explore the mechanisms between the association.
The other I have another two comments. One is on the future of this next study. Are you planning to follow them up? Because you have started another cross-sectional study, as I understood. I may have misunderstood.
You mean the Pearl River Delta study, or this
I was wondering what are your plans for following up these children?
in SNEC?
Yeah.
Well, I think maybe, well, we cannot follow that up because it's 10 years ago, and that actually this study was conducted when Professor Dong still in the Chinese Medical University, because the university located in Liaoning province, so they had to it's kind of easy to conduct it. So, but I think it's done, for the SNEC. And we switch to another, the Pearl River Delta study is the cohort study, because we conducted 2 rounds. The first is from 2016, and the second round is 2019 to 2020. It's a 4 years follow up for the Pearl River Delta study. And for the first round data, we already cleaned and do the crude, the analysis of the associations. Maybe we can talk about that more, and we can ask your suggestions on the analysis for the Pearl River Delta study, because that's the cohort. But for the SNEC, it's cross-sectional.
Yeah, so the second comment is irrelevant in that case, because I was thinking if you are planning to follow them up, probably, I mean, this is a good time to write a profile paper on SNEC. The International Journal of Epidemiology, they publish profile papers of longitudinal studies, but you could start with a cross-sectional study, and if it is going to be followed up, still you can publish that profile. But if it is not going to be followed up, then probably it's not going to be relevant. But I still feel, I think we had a chat when you were in Melbourne, I still feel there's an opportunity to consolidate all the knowledge and bring the findings together, because there is a lot that you have published.
I'm not sure that journal if they're interested in a cross-sectional study, because they publish the core.
Yeah. Thanks, Sean.
Yeah, thank you, Shamli.
We have a time for the last comment or question.
Yeah.
So if there's no question or comment, we will bring the meeting to a close. So thank you, Sawen, and everyone for attending the seminar today. See you in the next seminar.
Okay, thank you all. Thank you, Zeng.
See you later.
Echo.